Good evening, guys. I hope everyone can hear me loud and clear. My name is Tepang. If you did not manage to join us on Monday, a warm welcome to you. Whether you're joining us live from TikTok or Zoom, a warm welcome. Please invite your friends, share the link, your classmates, or anyone you know is in grade 11 and would benefit from this session. Please do invite them. We are going to get started. The time is 6 minutes after 6 o'clock. I'm going to start sharing my screen. And then today we are going to be looking mainly at paper 1 topics. We're going to be looking at a lot of algebra and functions. So please make sure that you do have your pen and paper ready, and also make sure that you have your calculator. Make sure that you do ask as many questions as as necessary, excuse me, and we'll try by all means to answer them. You are allowed to use the Q&A to ask your questions. If you're watching live from TikTok, please use the chat to ask your questions. All right, without further ado, let me share my screen and then we start with today's session. It will be a little bit fast because there's so much that we need to do, but I'll still make sure that you do understand everything that we are doing. Okay, I'm going to stop my video now that you've put now that you've put a face to the voice. I'm going to stop sharing my video so that we can conserve data and we can have a better connection. Okay, you should be able to see my screen in a second. There we go. Okay. So let's look at this. We're going to be looking at algebra, equations and inequalities. Okay, so there's a workshop on that. The first thing that I want us to focus on would be quadratic equations, okay? Now, when you are factorizing or factoring polynomials, the 4 important things that we need to look at are the greatest common factor or highest common factor, if you may. We learned this in grades 8 and 9. And then also look at your special cases. Right, so this is highest common factor. Just a second, let me switch on this thing. So highest common factor. And then for special cases, number 2, we need to look at the difference of 2 squares. So a squared minus b squared. Right? Or look at this case, a squared plus 2ab plus b squared. This is when you have a plus b all squared. Alternatively, you're going to look at the difference of a cube, a to the power of 3 minus b to the power of 3. And finally, this is supposed to be a plus in between, the sum of a cube. You need to remember these. Unfortunately, they are not given on a formula sheet. So you have to do a lot of practice. Right. Also, you can factor by decomposing whatever sum they have given you, or you can factor by grouping. So you put apples in one basket and bananas one basket. So what I mean by that is you'll group the x's together, the numbers together, or the y's together, or whatever letter that was given to you. Okay. Now let's start with factorizing. So here it says, factorize x squared plus 13x plus 22. This is equal to 0. So I want us to factorize and solve for x. That should be quite easy. We know we're going to have 2 brackets that are equal to 0. Okay. Now, we're going to have x and x, because if we multiply x by itself, we are going to get x squared. Now we want 2 numbers, but these 2 numbers, when we multiply, so we want 2 numbers such that when we multiply them, we're going to get 22. But when we add or subtract them, we need to get a 13. And then I know that those 2 numbers are going to be 11 and 2. 11 and 2 does give us 22. And if you say 11 plus 2, you are going to get 13. Now let's look at our signs. Our signs are going to be positive and positive. Now this simply means x is equal to negative 2 or x is equal to negative 11. That's quite easy. I think everyone is with me there. Right, if you're taking this down, I suggest that you take a screenshot so that you can listen instead of taking notes while I'm explaining. So when I'm done with the answer, you can just quickly take a screenshot. But the recording will be made available. It will be uploaded to our YouTube channel. The link to our YouTube channel will be shared at the end of the lesson. Okay, now here's a different type of factorize that we need to look at. So this shouldn't be a problem at all. What do we have? We have power 2 and we have another power 2 in there. Right. What can we do here? Firstly, let's say let x to the power of 2 minus 3x is equal to something else. I'm going to say it's equal to k. The reason I'm saying it's equal to k, so that I can have k squared minus what? Minus 8k squared minus 20 is equal to 0. Hope everyone is with me. Because x squared minus 3 is equal to k. So, but there's a 2 there, and there's another 2 here. Now, let's simplify this. What are we going to have? We're going to have minus 7k squared is equal to 20. Let's erase that. Then we can solve. So this is going to be k squared is equal to 20 over negative 7. Okay, now we know that we're going to have no solution here only because we have a negative, and the square root of a negative is going to give us no solution, right? But I was just showing you that you can substitute something else, right? Because you do not want to deal with x to the power of 4. It'll be very difficult for you to factorize that. So always look out for what you can substitute. So usually we say this is a relevant substitution. Okay. Moving on. Quadratic inequalities. So these are some of the steps that will help you solve those quadratic inequalities. So in the earlier grades, you were solving linear inequalities, but in grade 11 and in grade 12, you are going to be dealing with quadratic inequalities where you have two factors or two solutions. Now, how you go about answering those questions is you have to find the critical values by solving as a regular equation. So you imagine that this sign, the inequality sign, greater or equal, or whatever sign that they gave you, imagine it as an equal sign, but you do not write that equal sign. It's very important that you don't write the equal sign. You write whatever they gave you, but you imagine it as an equal sign so that it's a simple equation that you can solve. Once you have solved, once you've found those x answers, you're going to put those answers, right? We call them CVs, critical values, on a number line. And then you're going to consider the shape of the parabola or test values between and around the critical values to see which interval or which intervals satisfy the inequality. So these are the steps that will help us solve for quadratic inequalities. And we are going to deal with some inequality problems, and we're going to apply this so that you can see how you need to go about it. Right. My personal favorite is finding or drawing the parabola and then checking whether it's above the x-axis or below the x-axis, because a lot of students get confused with the number line, although we are ultimately doing the same thing at the end of the day. So please take note of this. This is what we're going to do when we start tackling those questions shortly. Now, surds, right? How do we deal with surds? So the first thing that you need to do is make sure that you isolate for the square root. Okay, so isolate the square root. We're going to say 3x minus 5. This is just an example. This is equal to 9 minus 8. We want to isolate it. You cannot square like this. This will not work for you. Please do not do that. Isolate first. Once you've isolated, let's check if we can simplify. Can we simplify this? We definitely can. Now that we've simplified, we can square both sides. So let's do this. Squared, squared. On the left, what do we have? We have 3x minus 5 is equal to 1. And then 3x is equal to 6. Then x would be equal to 2. And that's how you would deal with a simple surd. Right? We are still going to deal with more questions. Okay. Then nature of roots. Right? A lot of students struggle with these kind of questions when they ask you about nature of roots. Let's try to solve it now. Right? Now, remember that the general quadratic equation, right, comes from ax squared plus bx plus c. It comes from this standard form, right? Now, the quadratic equation, we all know it. You don't have to memorize it, and you don't have to know where it comes from, but we found it by completing the square, right? Luckily, you don't have to know the proof, but we've completed the square for this equation, and we found the quadratic formula. Now, you need to remember something. We just said, whenever you are trying to find the square root of a negative number, right, it will give you an error on your calculator. You can check square root of any negative number. It will say error, right? It will say math error because it's an imaginary number that we don't have to worry about at this stage. So let's look at our quadratic formula. Here's the square root. Okay, now under our square root, we have b squared minus 4ac. We usually refer to this thing as delta. So delta is equal to b squared minus 4ac, okay? Now we're going to deal with the cases. Case 1, if delta is greater than 0, you're going to have what? 2 real roots. Hope we're all together there. Make sure that you're with me. If delta, remember what delta is. Delta is b squared minus 4ac. If that is positive, then you're going to have 2 real roots. Second case, if your delta is equal to 0, you have 1 real root. Okay, sometimes they say repeated roots. Okay, let me just draw so that you can see what I mean there. So for 2 real roots, it can be something that looks like that. 2x intercepts, that's what we mean by 2 real roots. Can even be a happy face as long as we have 2x answers. 1 root would be the turning point on the x-axis. As you can see, it's just 1 root or repeated roots. Lastly, if you have delta being less than 0, that's when you have an error on your calculator. If your delta is less than 0, then what do you have? You have no solution or no real roots. And what does that mean? It means that you have this case. Your turning point is above the x-axis, or it can be below the x-axis. It doesn't touch. And those are nature of roots. Make sure that you do understand these cases. And you need to pay attention to what the question is asking you. Are they saying for which values of x will the equation have 2 real roots? If they're saying 2 real roots, you must say that your delta is greater than 0. If they're saying repeated roots, your delta must be equal to 0. If they're saying no roots or no real roots, your delta must be less than 0. And remember, once again, delta is b squared minus 4ac. Okay, bear that in mind. Now, let's quickly try to apply this whole delta thing. Okay, so here they're saying, find the values of k such that f of x minus g of x is equal to k has real solutions. This is very important. Real solutions. Okay, now they said it's a plural, so it means it's going to be 2. Okay, this is going to be which case? It's going to be the very first case. Now, f of x minus g of x. F of x is just 2x squared minus 3. Minus what? Minus x squared minus 2x is equal to k. Hope everyone is with me there. I just subtracted g of x from f of x. Now we're going to have 2x squared minus 3 minus x squared plus 2x is equal to k. Remember, you need to put these brackets, otherwise you are going to have some problems because the negative needs to affect that, and also it needs to affect the negative 2. Right. Then we're going to have this. We're going to have x squared, because these two deal with each other, plus 2x minus 3. Let's bring the k from the right to the left-hand side. We're going to have minus k is equal to 0. Now, I want to point out something. A is equal to 1 in this equation. B is equal to 2. What is C equal to? C is equal to negative 3 minus k. So this whole thing here is your C value, not just the negative 3. Hope everyone is with me there. The C is minus 3 minus k. Now, let's solve. Delta has real solutions. So, or this has real solutions. So we must say delta must be what? Greater than 0. As per the cases that I gave you, what is delta? We know that delta is b squared minus 4ac greater than 0. Let's substitute. What is b? It's 2, but it needs to be squared. Minus 4. What is our a? It's just 1. What is our c? Minus 3 minus k greater than 0. Hope everyone is with me. Make sure that you're following every step of the way. Right. Don't try to take notes down. I'll give you a few seconds to take some screenshots. Make sure that you are listening to what I'm saying. Then we're going to have 4 minus 4 times 1 is just 4. Into what? Into negative 3 minus k greater than 0. I don't want to skip any steps. Now negative 4 multiplied by negative 3, that's going to be positive 12. Negative 4 multiplied by negative k, that will be positive 4k greater than 0. Then it's just a matter of solving. 4k, 4 plus 12 gives us 16. Take it over to the other side, negative 16. Divide both sides by 4 so that k is greater than negative 4. And this would be our final answer. Hope it made sense. Okay, but don't worry, we're still going to do more questions from past papers on this. Okay, can take a screenshot, give you 10 seconds to do that. K is greater than negative 4, and this was the question. Okay, moving on. One of the easiest ones ever, simultaneous equations. You cannot afford to get this question wrong. Okay, let's look at some of the steps there. How are we going to solve this? Firstly, we identify the easiest equation, right? So remember, the top one will be our equation 1, and The second one, or the bottom one, will be our equation number 2. So from these two equations, which one is the easiest equation for you to solve? It looks like 1 is the easiest equation because it doesn't have any square, right? Now I'm going to say from 1, x is equal to 3 minus y. Now that we have such a thing, I'm going to call this new thing that we just found equation number 3. All right? Then we're going to say sub equation number 3 into 2. I always say to my learners that when you're at the stage, make sure that you do have 1, 2, and 3. You must have all 3 of them. You can't have 1, 2, 2, or 3, 2, 2. You must have 1, 3, and 2. The order doesn't matter as long as you have 3. Okay, so 1, 2, and 3. We're on the right track. Now let's do the actual substitution. We need to substitute equation 3 into 2. So we have 2. Suddenly I'm seeing an x, but it is squared. Okay, what is x? We found it to be 3 minus y. Then the squared is there, plus 4. There's another x. This is 3 minus y. Multiply by a y. But check what I'm going to do. Instead of writing this y here, I'm going to write it next to the 4 because multiplication is commutative, right? What do I mean by that? I mean that if you have 3 times 10 times 2, it's the same as saying 3 times 2, then times 10. The order of multiplication does not matter. Okay, that's why I put the y here in front of the 4, or just after the 4. Then it's minus y is equal to 15. Now let's clean this up. This is going to be 2 into, remember, the one mistake that you can make is to bring this here. You cannot do that. That squared means you need to write 2 brackets. I'm going to do it step by step for you. Just like that. Then plus 4y into 3 minus y equals to 15. Okay, now this is going to be 2 into, now we FOIL it out. Let's FOIL this out. And remember, it's not the difference of 2 squares. So be very careful. This is going to be 9 minus 6y plus y squared. 3 times 3 is 9. 3 times negative y is negative 3y. And the n is going to give us negative 3y. When you add the 2 up, you're going to get negative 6y. Negative y multiplied by negative y will give you y squared. Plus 12y minus 4y squared minus y is equal to 15. Hope everyone is with me. There are no questions. So I guess everyone is still following. Now, let's get rid of the brackets. 18 minus 12y plus 2y plus 12y minus 4y squared minus y minus 15 is equal to 0. Are there any like terms? Okay, I see I forgot a squared here. Just included that squared that I forgot. Are there any like terms? They should be. This and that, I'm going to have negative 2y squared. So I'm done with these two. Anything else? Negative 12y plus 12y. These two subtract each other out. Then what am I left with? I'm left with a negative y. Negative y. And then lastly, we're going to have 18 minus 15, which is simply going to give us negative 3 is equal to 0. Okay, if you want to clean it up, you'll say this is 2y squared plus y plus 3 is equal to 0. Then we try to factorize. It's plus and plus, so we're going to have a plus here and another plus d. 2y and a y. I hope that this works out. Now, if I say this is going to be a 1 and a 3, let's check if it works out. So first, I'm going to have 2y squared, and then inner, I'm going to have 2y, 3y, which is going to give me 5y. So this doesn't work out. Okay, and if it doesn't work out, also if you're struggling to factorize, you can always use the quadratic formula. Okay, there's a question. It's positive 3, not negative. Okay, let me just double check that I haven't made a mistake. Perfect. Thank you so much. Yes, absolutely. I do make mistakes and I appreciate that correction. This is not supposed to be a negative 3 because I have 18 minus 15. So this should be a positive. Thank you so much for that correction, guys. Really appreciate it. Okay, it means that you guys are paying attention. Okay, I had made a mistake, but we have fixed it now. So let's try to clean this up. So if it's a positive 3, what I have is 2y squared plus y. Then we're going to have minus 3 is equal to 0. Okay, now let's see if this works. Trying to factorize this positive and negative. So 2y, not 3y, 2y. Just a second there. So 2y and y. That should give me 2y squared. Then 3 and 1. So if I said 1 here and 3, let's check if it works. So we're going to have FOIL first. That's going to be 2y squared. And then we're going to have negative 2y, positive 3y. That works. So it means that y is going to be 3 over 2 negative, or y equals to positive 1. Now, we just need to substitute. Then we're going to what? Sub y values into equation 3. Even if you sub into 1, it would work. But don't sub into 1 because you have already solved for x. So take it from equation 3. So x is equal to 3 minus the y value, which is negative 3 over 2. Or it will be 3 minus the y value, which is positive 1. From here, it's just calculator work for you to find those two x answers. And that's how you need to go about completing, sorry, not completing the square, but solving simultaneous equations. Okay, let me zoom out in case you want to take a screenshot quickly. This is the question and the solution. Perfect. Now, this is one that I'm going to let you guys attempt, but we'll attempt it at a later stage. I want us to quickly look at some of the other slides there. We are going to come back to these questions here. Don't worry about it. Quickly want to touch on exponents as well. Let me just go back to my 100% zoom. Okay. So how do we deal with these kinds of questions? Okay, now if you try to plug this in your calculator, it's not going to work. The numbers are quite big for the calculator to try and compute. What you need to try and do is look at the smallest exponent. Okay, what is the smallest exponent? It would be 1006. So then you're going to say let 1006 is equal to x. All right, now let's check something. I'm going to say this is 3 to the 2015. Okay, but now I've just noticed something, that I have a 3 here and a 3 there. But this is not a prime. So now it's going to affect this answer. Now I need to go back. Okay, let me just erase. I'm going to write down the steps here. Firstly, prime numbers, prime bases. That's the first thing that we need to solve. 3, 3, perfect. So what we have is actually 3 to the 2015 minus 3 to the 2013 all over. What is 9? 9 is the same as 3 to the power of 2. That is a prime. Okay. The power here is still 1006. Now let's clean it up. 3 to the 2015 minus 3 to the 2013. If you see any mistakes, you are more than welcome to correct me, but I'll try to pay extra attention so I don't make any silly mistakes. Then we multiply, we're going to have 3 to the 2012. Now we're winning. The smallest power. What's the smallest power? It would be 2012, now that everything is in prime basis. So we're going to say let 2012 equals to x. The reason we did that, we can say the denominator will be 3 to the power of x. Okay. Now, here we have 2015. 2015 is the same as what? 2015 is the same as 2012 plus 3. Okay, which means I'm going to say this is what? 3 to the 2012 plus 3 minus 3 to the 2012 plus 1. I want to do it step by step. Okay, let's address the question in the chat. Okay, why do the signs change? Okay, I'm not too sure which signs we are talking about, but I haven't changed any signs so far. So if the question is a little bit clearer than that, I will answer it. Okay. Then let's come back here. This is going to be 3 to the 2012. We know it's x plus 3 minus 3 to the x plus 1 over what? Over 3 to the x. Now we can take out a common factor of 3 to the x. So 3 to the x into 3 to the 1 minus what? Minus 3. Sorry, this is not 3 to the 1, but this is going to be 3 to the 3. Just like that. Okay, then we're going to have 3 to the x. It's just a matter of canceling. What can cancel? This cancels that. What are we left with on top? 3 to the power of 3 will give us 27. And then 3 to the power of 1 is just 3. This is going to be 24. Okay, so there's a question, why plus 1 on the other side? Okay, I'm assuming you are talking about this plus 1. Remember where we started? We had 2013, but we said we want the relationship between 2013 and 2012. Isn't it that 2012 plus 1 is the same as 2013? Okay, sorry about that. 2012 plus 1 is the same as 2013. So the reason we say 2012 plus 1 is because we want to try and get, we want to try and manipulate it to get 2012 because we said that 2012 is x. So if you can check here, I have 2012. I have 2012, which is what I need because here I had 2012. okay? And then you just take out a common factor. There is an alternative way where you take the biggest and then you subtract. And I've seen that a lot of students get lost there, okay? That is why I always take the smallest one and I add from there. Okay. Somebody's asking me to repeat the question. I'm just aware of time. We still have quite a lot of things to do. We will come back to this question provided that we have time at the end of the lesson, because I did go over it again. Somebody's asking, I don't understand the part where 1006 became 2012. This is because this 3 multiplied there. Remember, initially we had a 9. 9 is the same as 3 to the power of 2. The 2 multiplies 1006. 2 multiplied by 1 is just 2. And then multiplied by the 6 there, it becomes 12. And that's how we got it to be 2012. Okay, we don't pick the denominator to make it x. We pick the smallest power. We pick the smallest power and we make it x. That's what we did. Okay. Now, finally starting with questions. Okay, so the very first question here says, solve for x. This question is for 2 marks, right? There isn't a lot that you need to do. You just need to give us those answers because already they set it to 0. They equated it to 0. So we can immediately say, just break this. We can immediately say that x equals to -5 or x equals to 7/4. And we get our 2 marks. Now, the next one is very important. Correct to 2 decimal places. You cannot factorize it. You have to use the quadratic formula, which is given on the formula sheet. Okay, so x equals to -b plus or minus square root of b squared minus 4ac all over 2a. Then we have -2 plus or minus. Here, check what I'm doing. I need you to do what I do as well. -2 squared is not equal to -2 all squared. These two things are not equal to each other. The left is going to give you -4 and the right is going to give you +4. So what we're doing here is we're saying -2 squared minus 4. What is A? 3. And C? -14. This is all under a square root. All over what? All over 2. And then our A is 3. Hope everyone is with me there. And then from here, it's just going to be calculator work. Right. If you're going to plug it into the calculator, make sure that you plug it exactly like it is. Obviously, for the plus and minus, what you're going to do is you're going to say, you're going to start with either the plus or you're going to start with the minus. Hope everyone is with me there. And then your x answers. Okay, here's a question in the chat. Let's quickly address that. Okay, so remember, if you're going to ask me to explain, you need to be very specific. Somebody's saying, I don't understand, please explain. Sir, I don't know what you don't understand. So be very specific. So I don't understand the second line, the third line of question 1.1 or 1.2. Right, so our x answers will either be 2.52 or x will be -1,85. And we just got that from the calculator. Make sure that you have input the signs correctly. Somebody saying it's giving me an error. There are two negatives. There is this negative and there's this negative. Okay, so the x values can be positive, they can be negative. Remember that this is a quadratic function. We don't know where it is at the moment. It could be somewhere here. It could be like that. They could be both negative, they could be both positive, or one could be negative and the other one could be positive. So we cannot discard anything at the moment. Perfect. Moving on. Now, those steps that I was giving you for the inequalities, let's try to use them now to solve 1.1.3. X squared plus 7x plus 12 is less than or equal to 0. Okay? Now, we're going to say, remember what I said, think of it as an equation, a normal equation. So, if it was x squared plus 7x plus 12, I'm going to use red here, is equal to 0. We're not supposed to write the equal sign. That's why I'm using the red marker there. Can we not factorize this? The reason I wrote an equal sign is because I know it looks like something that we are used to. It's not intimidating anymore. Still equal to 0. Can we not factorize this? We definitely can. X and x, two numbers that are going to give me 12. It's either 6 and 2, but that's not going to work. 3 and 4 can definitely work. They're both going to be positive. So once we're here, we're going to say CV, state them, -4 and -3. Those are your critical values. Then go back, remove this. What was it? It was less than or equal, less than or equal. They will penalize you if you put an equal sign there. So be very careful. Now that we have our critical values, we're dealing with a quadratic. It's a parabola. The a value is +1, meaning that it's a happy-faced parabola. Okay, that passes through the points, -4 on the left and -3 on the right. The parabola is going to pass through those points. And it's a happy-faced parabola. Then, what did the question say? Less than 0. What does this part mean? What does this mean? It means negative. So negative, it means what? Under the x-axis. Where's the graph under the x-axis? This is where it's under the x-axis. This is that region under the x-axis. How do we represent that region? We're going to say x lies between -4 and -3. And that is our answer. Alternatively, you could have said x is an element. There's a hard bracket on -4 going all the way to -3. Okay. Now let's address some of the questions there. If there's a negative and we need to divide by -1, the sign has to change. Absolutely. So if you're dealing with inequalities and you divide by a negative number, you have to change the direction of the sign. If it was less than, it has to change to greater than. Are we allowed to use quadratic formula on 1.1.3? Absolutely, you can use the quadratic formula to find the critical values. Okay, when do we apply selection for the two x values? Okay, so this is the selection that we're talking about. So I'm pretty sure you normally use the number line. I don't use the number line, I use the quadratic. Okay. So if you were doing the number line, it would simply be this, -4 and 3, right? Now, what you're going to do is you are going to then substitute values to the left of -4. You're going to substitute values to the right of -3. And then you also have to substitute values in between -4 and -3. You see, it's a lot of work so that we can see which values are going to give us positive. If we substitute maybe -10 here, it will give you positive. Maybe you substitute a 0 here, you're going to get positive. But if you substitute -3.5, you are going to get a negative. Then it shows you that the values between -4 and -3 are the ones that are going to give you negative. There is a lot that we need to do there. That's why I prefer the quadratic. Okay, moving on. 1.1.4, x to the power of 2 over 3 is equal to 4. I want you guys to help me solve for x here, right? The question is going for 3 marks. It shouldn't be that much work, right? So I'm going to give you guys 45 seconds to try and solve for x. So x to the power of 2 over 3 is equal to 4. If you have an answer for me, please do post it in the Q&A or in the chat. I'll give you 40 seconds to try and work it out. If you have an answer already, please do share. I will note it down, okay? I'm getting 2 answers, both saying x is equal to 8. Okay, you have 10 seconds if you're still working it out. We're all getting 8. Okay, perfect. Thank you so much for attempting this question. Let's check, how do we go about this? So this is the same as, firstly, I'm going to say, I'm going to multiply here by 3 over 2. But if I'm multiplying there by 3 over 2, I need to do the same thing here. Then these are going to cancel on the left-hand side. And then here I have what? 2 to the power of 2 times 3 over 2. These 2's cancel each other out, and x is definitely going to give us that 8. Just like that. That's how we need to go about that question. Thank you so much for attempting it. Now moving on. Now we're dealing with the surd. We need to solve for x. And I gave you instructions. I gave you a set of rules that you need to follow to try and solve for x. Let's do that. There's one that I did as an example. I'm going to give you guys 45 seconds to attempt this question. I know I'm not giving you enough time, but I'm also training you for the exam. Remember, you have about 3 hours, which might look like a lot of time, but the questions are quite demanding. So it's best that you try and work under, maybe give yourself 2.5 hours when you're practicing, so that you know that the 30 minutes is for you to go back and check if you've made any mistakes, right? Okay, somebody saying square both sides. Immediately, you can definitely square both sides, Maklatsi. That's correct. So let's quickly try to solve for x here. You have 40 seconds left if you're working it out. I urge you to attempt these questions with me. Okay, let's quickly check. What can we do here? Square both sides. So we're going to have 3 minus 3x is equal to x plus 5 all squared. Instead of saying all squared, I'm going to write 2 brackets. Do not be tempted to bring the 2 in. 3 minus 3x is equal to x squared plus 10x plus 25. Clean it up. X squared plus 13x plus 22 is equal to 0. Can factorize x plus plus. This will be 11 and 2. So x equals to negative 11 or x equals to negative 2. Now we need to check which value doesn't work, right? And you have to substitute. You're going to substitute the negative 11, you'll see that it doesn't work. But if you substitute negative 2 in the original, you'll see that it does work. So x is going to be negative 2. And that is how you deal with that question. Okay, can quickly take a screenshot, but let's quickly move on. Now, solve simultaneously for x and y in the following set of equations. Right. Now, this one is set nicely for us because it's already solved for x. We don't have to find equation 3. You see that it's already solved for x. So we can immediately say, well, this is equation number 1, and this is equation number 2. Now, only because it's set, right, to 2y plus 1, we can immediately say sub 1 into 2. Check what we're going to do. 2y plus 1, which is squared. That's why I'm writing 2 brackets. Minus 2y plus 3. I'm going to bring the y in front, and then I have x, which is 2y plus 1. This is equal to 6. And then we're going to have 4y squared plus 4y plus 1. Then minus 2y plus 6y squared plus 3y minus 6 is equal to 0. We can clean it up. We're going to have 10y squared plus 5y minus 5 is equal to 0. Can clean it up even further by dividing throughout by 5 so that you have 2y squared plus y minus 1 is equal to 0. We can factorize this. If you cannot factorize, I urge you to use the quadratic formula. It's going to be 2y minus 1, y plus 1. So y is going to be positive 1 over 2, or it's going to be negative 1. Now solve for x by substituting these y values. So x is equal to 2 into 1 over 2 plus 1, which is going to give you 2, or x is equal to 2 into negative 1 plus 1. And that should give you negative 1 as the final answer. And that is how you would deal with this kind of a problem when they have solved for x. They've made your life easy. You didn't have to find equation number 3. Okay, can take a screenshot quickly, then we move on. Now, here are more exponents. Just gonna make them a little bit bigger so we can clearly see. Okay, these ones are quite easy, right? I'm gonna let you guys attempt the very first one. It says simplify, right? So the question is 6 to the power of x plus 3 multiplied by 2 to the power of x minus 1 all over 12 to the power of x plus 2. How would you go about such a question? Right. I'll give you guys a minute for that question. So please do attempt it. We're going to mark just now. You have 55 seconds left. Once you have an answer, please do share it in the chat. If you're watching live from TikTok, you can share your answers in the chat. If you're here on Zoom with us, please do share your answers in the Q&A. And remember to share the link with your friends or classmates or anyone that you know. It could be family, you know that they can benefit from these sessions. Please do share the link with them. Remember to like and follow us on our different social media accounts. You have 40 seconds left if you're working it out. We're going to mark shortly. If you have an answer for me, please do share it. You can just give me the final answer. You won't be able to show me all the steps. I'd really just appreciate the final answer, and then we're going to mark it together. Okay, somebody got 9/4. Okay, I'll just note it down. I'm not saying it's wrong or right. I'm just acknowledging your answer. Thank you so much for attempting. There's also a 1/4. If you have a different answer, please do share. Okay, looks like most of us are getting 1/4. Okay, and then there's also a 3/4, which is quite unique. All right, let's quickly check how we need to go about this question. Okay. Remember, whenever we're doing exponents, we need to look at the prime basis. So 6 is not a prime number. I'm going to change it to 3 multiplied by 2. There's still x plus 3. Multiplied by 2 to the x minus 1. All over. 12 is not a prime. 12 is 2 squared times 3. On your calculator, it can find primes for you. If you have a Casio calculator, you just need to say 12, then say times 1, press the equal sign. It'll still say 12. Then you press Shift and then look for the fact button. It's under the square root. Once you've pressed Shift, press the fact button. Then it'll change it for you. Okay, but this is still to the power of x plus 2. Now, what does this mean? It means that we have 3 to the power of x plus 3 multiplied by 2 to the power of x plus 3 multiplied by 2 to the x minus 1 all over 2 to the 2x plus 4 multiplied by 3 to the x plus 2. Then let's try to clean it up. We're going to have 3 to the power of x multiplied by 3 to the power of 3 multiplied by 2 to the x multiplied by 2 to the 3 multiplied by 2 to the x multiplied by 2 to the negative 1. So the reason I write that is so that I can see exactly what cancels. All over 2 to the what? To the x multiplied by 2 to the x multiplied by 2 to the 4. It's 2x, remember. That's why I'm separating it to be 2x, 2 to the x multiplied by 2 to the x. Multiply by 3 to the x multiply by 3 to the 2. Now let's cancel what cancels. This and that. Anything else? 2 to the x, 2 to the x, 2 to the x, 2 to the x. Now, is there anything else? Yes, 3 to the 3 and 3 to the 2, right? So this and that just means I'm left with a 3 up there. Okay. Now, I'm just going to continue it here. I'm going to say I'm left with the 3 multiplied by what? By 2. These 2 are the same as to the power of 2 over 2 to the power of 4. I can simplify this further. This is just 3 multiplied by 2 to the 2, 2 to the 2 multiplied by 2 to the 2. These 2 cancel each other out. It means that our answer is going to be 3 over 4. Thank you so much for everyone who attempted that question. I'm hoping you guys can see where you went wrong. And this is how we learn math. We get them wrong and we correct them. Okay, great stuff. Now I want us to look at 2.1.2. Okay, let me just erase this, and I'm going to write it a little bit bigger so that you guys can clearly see. This is 3 to the 2x plus 6 multiplied by 3 to the x minus 27 all over 3 to the x. Then there's a minus 3 here. We're trying to simplify. I'll give you guys 1 minute for that one. It's only 2 marks. Shouldn't take you guys too much time. Okay, let's quickly check how we need to go about this question. Okay, so the one thing that I'm seeing already is there is a relationship between these two things. Okay, now this is the same as 3 to the x multiplied by 3 to the x plus 6 multiplied by 3 to the x minus 27. Remember, 3 to the x multiplied by 3 to the x is the same as 3 to the power of 2x. This is still over 3 to the x minus 3. Okay. Now we can factorize this, but we can even make it simpler for ourselves by saying this is the same as 3 to the x is equal to k. This would mean that you have k squared plus 6k minus 27 over what? Over k minus 3. Then check. We don't need this anymore. Let me just clean this up. Let's factorize the top. K plus and minus, because we have plus and minus. Then we need 27. So I'm going to say it can be, so 9 and 3 will give me 27, but will I get the 6 in between? Yes, I will, because it's 9 and 3. So I'm going to say this is a 3 here and a positive 9. K minus 3. Check what cancels. This cancels that. What are we left with? K plus 3. But what did we say K is? K is 3 to the x plus 9. So this would be your final answer. And that's how you deal with such a question. Okay, so there's a question you canceled 3 to the power 2 and 3 to the power of 3. No, I did not cancel them. I see what you're talking about. So you're talking about this part here and that. So this is 3 to the power of 2 and this is 3 to the power of 3. I only canceled the power 3. So 3 to the power of 1 is remaining. So it's like saying 3 to the power of 2 multiplied by 3 to the power of 1 over 3 to the power of 2. These cancel out. There's still 3 to the power of 1 that's left. That's why I've only canceled the 3. There is still a 3 that is left. Okay, quickly going to run over this again. So this was the equation. And we said, let 3 to the power of x become k. Okay, so 3 to the power of x is equal to k. We broke this down. Here it is. 3 to the power of x multiplied by 3 to the power of x. Remember, when bases are the same, you add x. When bases are the same, you add the exponent. So x plus x will give you 2x. Then plus 6, 3 to the power of x minus 27. Now, because we said 3 to the power of x is equal to k, this is k multiplied by k. K multiplied by k will give you k squared plus 6k minus 23. Sorry, minus 27. All over k minus 3. You factorize the top. If you can't factorize this, quadratic formula is your friend. Then you cancel what can cancel. You substitute back what k is. Because in the beginning, we said that k is equal to 3 to the power of x. We substituted back there. And this would be the final answer. We cannot simplify it further than this. Okay. Now let's quickly move on. Next thing that we need to look at are functions. This is a big one. Okay. So I'm going to need your undivided attention here. So we're going to be looking at question 5 here. What does it say? It says that the lines y is equal to negative x plus 4 and y equals to x minus 2 are the axis of symmetry of the function minus 3 all over x plus p plus q. Show that p is equal to -3 and show that q is equal to 1. Okay. Now, how do we go about such questions? I need you guys to pay extra attention. Functions is a very big section, which is not too difficult at all. I'm going to say x minus 2 must be equal to -x plus 4, because these axes of symmetry will touch each other somewhere. All right. Now, 2x will be equal to 6. Took the x over to the other side. Then x is equal to 3. Now, what do we know? We know that x minus 3 is equal to 0 if we just bring the 3 over from the right to the left. Okay, that's why we can immediately say that p is the one that is equal to -3. Now, moving on, we can say y is equal to x minus 2. Then substitute the x value, 3 minus 2, and we have 1. This simply means that q is equal to +1. As easy as that, we have found the values. Okay, let's address some of the questions that are in the chat. Okay, some questions won't be able to factorize like that. Can you please give us a better method? So the alternative method, right? So there isn't an alternative method for this particular one. What you have to then do is, if you have a different question, you then probably have to find everything in prime basis and then take out a common factor. Here, we couldn't take out a common factor. We had to factorize. Unfortunately, we had to factorize. We cannot take out a common factor for this one. Some questions you'll be able to take out a common factor and then easily cancel out. Okay, I'll try to slow down, but we don't have a lot of time and there's still quite a lot of functions to cover. Okay, somebody's asking why P? Okay, now that's a good question. So because we have it in this form here, right? Remember that if we take it from the formula, x plus p is equal to 0. Right. Now there's a relationship. Can you see that it looks the same as x plus a -3 is equal to 0? There's a relationship between those two things. And hence p is the one that is -3. Okay. I'm going to repeat the question. Just going to run through it again. So what I did is I equated the two straight lines, right? Why? Because these are the axes of symmetry. They will touch each other some way. I can definitely equate them to each other. After equating, I solved for x. Here I solved for x. And then I said x is equal to 3. Now, if x is equal to 3, I decided to take the 3 over to the left-hand side so that I have x minus 3 is equal to 0. Now, x minus 3 is equal to 0. It's the same relationship is related to x plus p is equal to 0. And hence, I said that p is going to be -3. After that, I took that p-value and I substituted in the second equation. If you wanted to substitute in the first equation, that's perfectly fine. You're still going to get q to be +1. Okay, so your marks, 1 mark there. x minus 3 is 0. And then your substitution and your final answer. Those are your 4 marks. Okay, let's quickly move on. Now, calculate the x-intercept of f. What is the equation? So the equation, okay, let me just write it here. F of x is equal to negative 3 over, we're going to say this is x minus 3, and then plus 1. Okay, I'm going to give you guys these two easy equations, these two easy problems to solve. The x-intercept of f and the y-intercept of f. So Gavit is asking, shouldn't q equals to negative 5? So the equation itself was negative this. So what I did is I substituted in this one. So it's going to be a positive 3 minus 2. Remember that we said x is equal to positive 3. And that's exactly what I substituted here. Positive 3 minus 2, which gave me 1. P is negative 3, but x is positive 3. Okay, now we're back to finding the x-intercept and y-intercept. Give you guys 1 minute for both those questions. Once you have an answer for me, please do share in the chat or in the Q&A if you are on Zoom with us. If you're watching live from TikTok, you can share it in the chat. Okay, I'm already getting answers here. Just going to acknowledge them. We have x is equal to 6. I'm just acknowledging the answer. I'm not saying it's wrong or right. Thank you so much for that. Okay, we got Atlerang who's saying x is equal to 6. Pumelele as well saying x is equal to 6. Okay, there's a y is equal to 2. There's also let y equal to 0. Okay, yeah, those are the steps. Because you're solving for x, you have to make y 0. Remember that for the x cut or the x-intercept, your y will always become 0. It looks like we are all in agreement here. Let's quickly check. Right, we're getting y is equal to 2 from multiple people. Thank you so much for attempting. Let's quickly check. So 0 is equal to negative 3 over x minus 3 plus 1. So I'm going to take this to the left-hand side. So 3x minus 3 is equal to 1. Then you can cross multiply. X minus 3 is equal to 3. X is equal to 6. So you have 6 and 0 there. That's how we got it. Now for the y-intercept, we make x 0. So y is equal to negative 3 over 0 minus 3 plus 1. And that's just going to be calculator work, but negative 3 divided by negative 3 is just negative, it's positive 1, sorry, negative 3 divided by itself, it's positive 1, plus 1, we're going to get 2. So here we have 0 and 2. And that's how we found those intercepts. A very easy problem there. Okay, now we are asked to sketch that graph. Okay, let me just move this. Sketch the graph of f, clearly label all intercepts with axes and asymptotes. Okay. Firstly, my Cartesian plane. This is the y-axis, that is the x-axis. Now for my asymptotes, so the equation was negative 3 over x minus 3, and then there was a plus 1. Okay, so I know I'm going to have an asymptote here, and this value is going to be 3. And then the other one is positive 1, so it's going to be somewhere here. Now we have a negative. That simply means that our graph is going to be in quadrants 2 and 4. When it's negative, it's in 2 and 4. If it's positive, it's 1 and 3. If your A value is positive, 1 and 3. If your A value is negative, it's going to be in 2 and 4. Now, we found intercept. We found 0 and 2. And where's 0 and 2? 0 and 2 is somewhere here. We have another point, which is 6 and 0. 6 and 0 is going to be somewhere there. And let's just sketch. And just like that, we have our graph. And be very careful that you never ever touch the asymptote. You can come closer to it, but you shouldn't touch it. So I'm just going to clean this up. It's a freehand sketch, so please do forgive me. But yeah, I'm not touching that asymptote. I'm just coming closer to it. Okay, let's look at some of the questions here. So explain the y-intercept. So the y-intercept, all we did is we made x 0. So remember, this is the equation. So you make x 0 here, and then calculator work if you're not too sure what we do here. So what I did is I say I have negative 3 over, what is 0 minus 3? It's negative 3. Then there's still a plus 1. What is this? This is a positive 1, plus 1. That's how I got my 2. Okay, then somebody's saying, why did you transpose the 3 over x minus 3 and negative 3 won't be positive? It doesn't matter. You can transpose the negative 1, and then you can transpose the positive 2, the positive 1, you're gonna have negative 1. So you wanted to say negative 1 is equal to negative 3 over x minus 3. Then you're going to cross multiply. Negative 3 is equal to negative x plus 3. Then you're going to take this over to the other side. X is going to be positive. You're going to take this over to the other side. It's going to be 3 plus 3. Then you have 6. Okay. Now, explaining the graph. The very first thing that we need to look at is the A value, right? Remember, we have f of x is equal to a over x minus p and then plus q. But the equation in this instance is going to be negative 3 over x minus 3 plus 1. What are our asymptotes? Our asymptotes are it's positive 3 because x minus 3 cannot be equal to 0. So the graph cannot touch at 0. So x is equal to positive 3. That's where this is coming from. And the horizontal asymptote is going to be whatever the q value is, positive 1. That's where I started. And then I said, because my a value is negative here, my graph has to be in quadrants 2 and quadrant 4. And then bear in mind that I did calculate x and y intercepts of this graph. Then I just found them. So I said, because I had calculated them, this is 0 and 2, and this is 6 and 0. I hope it's clear for everyone now. Please do take it down quickly. I'll zoom out in case you want to take some notes, take a screenshot. And then we move on. Perfect. Now they're saying, write down the domain of G if G is the reflection. Okay, let me zoom in. Write down the domain of G if G is the reflection of f along the line x is equal to 0. Okay, the first thing that we need to address is what they mean by the line x is equal to 0. That's the first question. Okay, let me just bring this up here. What is this line? Okay, just a second. There we go. My pen was misbehaving there. There we go. Perfect now. What is that in other words? That is the y-axis. Anywhere on the y-axis, x will always be 0. So for example, here, even if I went down the page, remember it's going down to infinity. At this point, x will always be 0. So the y-axis, the equation of the y-axis is always x is equal to 0. Then the equation of the x-axis is always y is equal to 0. I'm hoping that makes sense there. Okay. So we are reflecting it along the y-axis. Okay. Now we want to write down the domain. What do we mean by domain? So this is how I always differentiate between domain and range. I say domain. This is how I write my range. I write it with a y there. I know it's the wrong way to write range, but this simply means that I'm dealing with the y values. And if I'm dealing with the y values here for range, my domain, I'll be dealing with the x values. I hope it's clear. Our graph is going to then look something like, it's reflecting way. It's reflecting here, remember. So this 3 is now going to become -3. Now, let me maybe use a different color. Let's use blue. So now this is the asymptote that we have after reflecting. This asymptote is fine. Hope everyone is with me there. What does it mean? It means that our graph is now going to be something that looks like that. Never ever touch the asymptote. And it's also going to look. So we had 6 and 0. We're now going to have -6 and 0. So this way. That is the new graph. Now the domain are the x values. I just wanted you guys to see what the graph would look like. But you're going to say x is an element of real numbers, but x cannot be equal to -3. Because the graph does exist everywhere except at this new asymptote. Okay, somebody's asking, why didn't the +1 not change to -1? That is a brilliant question. Remember, we addressed this. The line x is equal to y. So only the x values are changing because we are reflecting along the y-axis. So the y value is not going to change. You're reflecting along the y-axis. So if there was a point here, which was maybe point A, which had coordinates, let's say -4 and 4. If you reflect this point along the y-axis, you are now going to have +4 and +4. The y value is not changing, only the x is changing. Okay, when somebody's asking, when A is negative, the graph should be in quadrant 2 or 4. When A is negative, the graph is in quadrant 2 and 4. So you have this. That's a positive, that's a negative A. When your A is positive, you have 1 and 3. Hope it makes sense. Okay, now let's move on. Sketched below is the graph of f of x is equal to x squared minus 4x minus 5, for x is an element from from negative infinity to +6, including the +6, right? So don't be alarmed when you get a question like this, right? It's a normal graph. It's just that they decided to end their graph at +6. So usually you would just say it goes on, but they just decided to end it there, to cut it off there. That's the only thing that they did. Now, the first question says, determine the value of f of 6. Right. I'm going to let you guys attempt that easy question. Okay, I'll go back to the domain, but we're quickly looking at 6.1 before I go back to that domain. Give you guys 10 seconds to just find the value of f of 6. The graph f of x, the equation f of x is given there, but you want f of 6, not f of x. Quickly calculate that. You can rely on your calculator for that. Once you have an answer for me, please do share it in the chat or the Q&A. Okay, perfect. We're getting f of 6 is equal to 7. That's what I'm getting on my side as well. The only thing that we did is we said 6 squared minus 4 into 6 minus 5, and we found what that answer is, and it gave us a 7. Okay. So somebody was asking me to explain the domain. So I'm pretty sure they're talking about the domain of this function, right? So let me just erase the green out. When we are talking about domain, we are talking about the x values, right? Where does the graph exist? The graph exists all the way here. Where is that pointing? Negative infinity. And the graph is pointing to the right. It's pointing at positive infinity. The graph exists everywhere for those values, except at this guy. It never ever touches that. And that is the asymptote. Because it's an asymptote, we can say x exists, so we can say the graph exists everywhere on the x values, right? But not at the asymptote. That is the domain part. It exists everywhere except at -3. Okay. Now somebody's saying they do not understand the question. I don't know which question you do not understand. You need to be very specific. I don't understand their question numbers there. So this is f of x. It's equal to x squared minus 4x minus 5. We don't want f of x. We're replacing the x with 6. Can you see the difference there? So wherever we see x, we're going to put 6. Another 6 minus 5. And we got a 7. You're finding the corresponding y value when x is 6. Okay, now they're saying determine the coordinates of A and B. I'll let you guys attempt that one quickly. You're finding these. And those are x-intercepts. Remember, for x-intercept, we make y0. I'll give you 45 seconds to attempt that question. As soon as you have an answer, please do share it in the chat. Don't be shy to share your answers. If it's incorrect, we're going to address it. And remember, that's how we learn math, by getting them wrong and then rectifying our mistakes. Okay, I'm getting A is -1 and B is 5. So let's just note them down. If you're working it out, continue working it out. I'm just acknowledging the answers that are shared in the chat. If you have different answers, please do share them as well. And thank you so much for participating, guys. You guys are making this lesson fun and interesting. Okay, let's quickly check. How can we find those coordinates? We know we are going to say 0 is equal to x squared minus 4x minus 5. 0 is equal to x. One is going to be positive, the other one is going to be negative. I'm going to have a -5 here because I need a -4 and a +1. So x is equal to -1 or x is equal to +5. Now, A is going to assume the negative value because it is on the left-hand side of the y-axis. And then B is going to assume the positive value. That's quite easy. You cannot afford to get that question wrong. Now let's see. Write down the equation of G in the form G of x is equal to ax squared plus bx plus c. If it is given that G of x is obtained by shifting f of x 2 units to the right and 5 units up. So this is very important. Let me highlight. 2 units to the right and 5 units up. Okay, let me see if I can move this up. Or I can just copy down the equation for you guys. It's right here. So f of x is equal to x squared minus 4x minus 5. So now you're moving it 2 units to the right and 5 units up. I'll give you guys 45 seconds to attempt that question. Do attempt it. Even if you don't get it right, please do attempt it. We're going to mark it together just now. Okay, I have an answer from Katlego. Katlego is saying that g of x is equal to x squared minus 6x. Thank you so much for attempting, Katlego. I'll give you guys 20 more seconds to attempt it, then we're going to mark. Somebody got 2x. I'm assuming that it's 2x squared minus 6x minus 5. Let's quickly check. We can say that g of x is going to be, what I want to do is I want to say it's x squared minus 4x, then leave some space, and then minus 5. Now, they said 2 units to the right. Because they said 2 units to the right, what is it going to become? Minus 2 minus 2. What else did they say? 5 up. Hope everyone is with me there. Let's clean it up. This is equal to x squared minus 4x plus 4 minus 4x plus 8. These two cancel each other out. Then we have x squared minus 8x. 4 and 8 will give us 12. This is the equation of g of x. Because they say 2 units to the right. So when we say to the right, we know, I said x minus 2 because if we equate it to 0, we're going to have x is equal to 2, positive 2, 2 units to the right. Be very careful of that. I'm going to quickly run you guys through this question again. So we're trying to find g of x, but we know that g of x is obtained by shifting f of x 2 units to the right. Whenever we shift to the right, we subtract. When we shift to the left, we add. Okay, because they say 2 units to the right, subtracted there from x. Furthermore, they said 5 units up. That's why I added a 5. And then this simply means 2 brackets. Don't bring the 2 in. It's very important that you don't bring the 2 in. 2 brackets. Expand everything. Multiply that in. So negative 4 multiplied by x will give you negative 4x. Negative 4 multiplied by negative 2 will give you positive 8. And this expanded is just x squared minus 4x plus 4. Add like terms together. You're going to get this equation. I know it was a little bit tricky, but these are some of the questions that they ask in exams. So you guys need to be practicing a lot of past papers. Okay, let's quickly look at this one here. Let me try to enlarge it. Okay, it gets a little bit better. So here they're saying the graphs of f of x is equal to negative The negative is outside, b to the x plus 8, and g of x is equal to 3 over 2x plus 7 are drawn below. You can immediately see that f of x is the exponential function, and g of x is the linear function. A, which has coordinates -2 and 4, and B are points of intersection of f and g. B is the y-intercept of both graphs. F and G. So B is the y-intercept of both graphs. Write down the coordinates of B. I'll give you guys 20 seconds to attempt that question. The coordinates of B. You don't even have to calculate. It's as clear as daylight. Usually when they say write down, they don't want you to do any complex calculation. Thank you, Katlego. The coordinates of B are simply going to be 0 and 7. Why they 0 and 7? We got them from the equation of the straight line. We know it's the y-intercept, so we made x 0 and we got our y to be 7. As easy as that. We get our 1 mark for that. Now, show that B is equal to a half. Okay. I'm going to say y is equal to negative b to the power of x plus 8. Then I want to substitute sub a, which coordinates -2 and 4. Then we're going to have 4 is equal to negative b to the -2 plus 8. Then we're going to have b to the -2 is equal to 4. I took this to the left. Sorry about that. I took this to the left-hand side and the 4 to the right, so that I have 8 minus 4, which gives me 4, and the negative b to the -2 becomes positive. Hope everyone is with me. Now, we dislike working with negative exponents in math. We're going to make that positive. 1 over b squared is equal to 4. Then we can cross multiply. So b squared is simply going to be 1 over 4. Then b is simply going to be plus or minus 1 over 4. And b is going to be plus or minus 1 over 2. Okay, then they said show that b is 1 over 2. We can simply conclude that b is the positive 1 over 2. Okay, hope that made sense. Can quickly take a screenshot there. Okay, moving on. Write down the average gradient between A and B. Okay, let's move this up. The average gradient between A and B. Okay, now that is one of the easiest questions ever because we have the coordinates of B, 0 and 7. So to find that average gradient, we're simply going to say 7 minus 4, which gives us 3. 0 minus minus 2, which is positive 2. And we get our 2 marks for that. Now, write down the equation of the asymptote of f. Write down the equation of the asymptote of f, and that is simply going to be y is equal to 8. One more than that y-intercept. You don't have to do a calculation. Okay. Somebody asked me to explain again. Remember, guys, you need to be very specific with what you need me to explain. Okay. I'll start with explaining that b is equal to a half. The first thing that we did is we took f of x, right? Because that's where b is located. G of x cannot help us. And then I substituted the point A, because the graph does go through the point A. You substitute. Your y is 4 and your x is 2, negative 2, not 2, negative 2. From there onwards, we try to solve for b. Take this to the left and the 4 to the right. Once you have this step, what you're going to do is you are then going to say 1 over b to the 2 so that you have it as a positive exponent. That's the step. 4 is the same as 4 over 1. You cross multiply. 1 times 1 is just 1. B squared multiplied by 4 is 4b squared. Divide both sides by 4. You're going to have b squared is equal to 1 over 4. And then you find the square root. Whenever you try to find the square root, it has to be plus or minus. Right? The square root of 1 over 4 is going to give you 1 over 2, but it's always plus or minus. And remember that b has to be greater than 0. Right? And in any case, they did say that b is equal to 1 over 2. That's why we are omitting the negative 1 over 2, and we're taking the positive 1 over 2. Now, for the average gradient, right? Gradient is just what? M of AB is equal to y2 minus y1 over x2 minus x1. 7 minus 4 over 0 minus minus 2. 7 minus 4 is 3. 0 minus minus 2 is 2. And that's how we got the gradient to be 3 over 2. Okay, then the equation of the asymptote. Remember, the easiest equation to think of is, so let's say we have such a graph. If this point is the point 0 and 2, it would mean that your asymptote is going to be 1 less than that y-intercept. If that's the kind of graph we're dealing with. But in this case, we have a graph that is under that that asymptote. Okay, the asymptote is just going to be 1 more than whatever that y value is. Right. It's also given here. That's the easy way to go about it. Take it from there. Because you needed to just write it down. The equation of the asymptote of f. Remember that this will always give you that asymptote. All right. And that's that for today. I hope you guys managed to grab something from today's session. And if you are going to be starting with your maths exams very soon, maybe Friday, I wish you all the best for those exams. Make sure that you guys study very hard. There are past papers on the government website. Please make sure that you practice those past papers. And I urge you guys to use the June papers because you haven't covered everything yet. So at least the June ones, they are set as per the annual teaching plan.